pleasant day to one and all. I am Ernesto Semari M. La Paz of Section 80 under the course GE4 Math in the Modern World, and in this task I will explain to you some of the topics that are covered under this course GE4. Let us begin with the first segment, Math and Nature. We have patterns. This refers to any repetitive arrangement or anything that follows a certain sequence. Keywords to take note, we have repeat or repetitive or repetition, as well as continuous or progressive. We have the types of patterns. We have symmetry, fractal, spiral, and tessellation. First, let's have symmetry. Symmetry is a pattern that shows reflection of images. Here are some examples. On the left side of the screen, we have the starfish, which is an example of radial symmetry. And on the right side of the screen or picture, we have the fly, which is an example of bilateral symmetry. We also have the bridge and the butterfly. Next, we have fractals. Fractals are repetitive patterns consisting of continuously smaller sizes and angles. An example of which is the Pascal triangle. Another is the fern. We also have the snowflake. And lastly, we have the aloe polyphylla, or the aloe plant. Next type, we have the spirals. These are patterns that originate from a central point and progressively radiate outwards. An example of which is the Fibonacci spiral, which is based on the Fibonacci sequence or the Fibonacci numbers 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and so on. Another example is the seed or the seeds of the sunflower, the giant wave, and the snail shell, which is a perfect example of the Fibonacci spiral. Lastly, we have the tessellations. These are patterns that repeat figures that are compactly contained, that is, they are closely fitted together. Here are some examples of tessellations. These are what you call the polygonal packing. We also have the honeycomb and the pineapple. Now let's go to the second segment, which is math language. First, we have sets. Sets are a collection of objects, and the set is represented with a capital letter. These are the types of sets. We have universal set, empty or null set, and the subset. Let's discuss about the roster method. So we have an example. A contains the set 3, 6, 9, 12, and 15. And set X contains the elements x minus 1, x, x plus 1, and so on. We have the rule method. Set B is or contains X. That is, X is the set of all odd composite numbers. And we also have set Y, which has the element X, wherein X is the set of all cities in Negros Island. The objects being collected in a set are called elements. We also have the universal set. Universal sets contain all elements of a given set, and it is denoted by the character U. Next, we have the empty set. Also known as null set, this is a set that contains no elements, and it is denoted by this symbol. We also have a subset. Subsets are sets of elements that belong to a certain set. So we have an example here. Let A, set A, B, or set A contain the elements A, B, and C. The subsets are as follows. And take note, empty sets are always subsets of each set or any given set. We have set operations, we have union, intersection, set difference, and complement. So union, from the name itself, the elements of all sets are combined to a singular set, just like the example here. Next, we have the intersection. What we need to remember here in the intersection is the common elements between the given sets, as seen in the example. Next, we have the set difference. This means that all elements that are in set A, or all elements that are in set A, are not seen in set B, as seen in an example. So we have 1 and 3. 1 and 3 are seen in set A but are not seen in set B. So we have also the complement. This is the last one. So given a certain set, the complement is a set of all elements in the universal set that do not belong to set A. And that's the time we have today. Thank you very much for listening, and we will see each other next time.